Thank you. So my name's Ian Russell. As Rich said, I've not been here for 4.5 years. I didn't think I was that bad last time, I have to say, but maybe I was. So that's my Twitter handle, IJRussell. I'm here to talk about functional C#. Unfortunately, there will be some F# as well, but it'll be in the context of C#. So what we're going to do, we're going to have a quick introduction and a basic idea of what functional programming is. It's a very high level view of it. I have a bit of a bitch about OOP and how much more wonderful FP is than it, but I'll try and keep it fair. And then basically we're going to do some code. You know, I think that's the best way to learn functional programming. So, functional programming, it's old. Based on the ideas of Alonzo Church, who did lambda calculus back in the 30s. Obviously functional programming didn't exist and computers didn't, but it's basically joint oldest or slightly not the oldest, depending on who you talk to and what programming language they're selling at the time. So it has been around for a long time. But it's not very popular, or it hasn't been very popular. Just the same as NoSQL actually predates relational databases by a long way, but then they disappeared off the face of the earth. And actually it's pretty much the same reason why. Computers just couldn't cope with it. You know, when I started computing, I mean, I started back in the yeah, the Stone Age. But I actually started with 5¼ floppy disks with a BBC B, but we'll not talk about that. But I started with very low-level computers, so 286s with kilobytes of memory, kilobytes of disk space. Everything mattered. And unfortunately, with functional programming, the way that functional programming works, you need a lot of memory to run because it throws stuff away, or it needs to throw stuff away. And unless you've got good garbage collection, or you've got that much memory, it doesn't make any difference. It doesn't work, or it doesn't work very efficiently. So there were better ways of working, and people seem to jump onto OOP. And we've been on OOP now for, well, I started with VB6. Smalltalk was 10 years before that. So probably the 80s. I'd love to say OOP was now dying out, but unfortunately it's not. But FP is beginning to come back. And it's coming back because we're now hitting some problems with OOP that we've never had before. So up until relatively recently, you had a single core computer. All right, it's fast, you had a lot of memory, but it was a single core. Now we've got multiple cores. You know, with a lot of functional languages, they also talk to GPUs as well, where there's thousands of cores. And if you've got mutable state, which is how object-oriented programming works, it doesn't work as efficiently across multiple cores, whereas functional programming does. And that's the same thing that's happened with NoSQL. You know, now that it costs, you know, £50 for a 5 terabyte disk, or whatever the costs are now, you know, storage is nothing any longer. But in the relational days, it was important. You only stored one bit of information, you know, one copy of information. Now that's gone. So people are now jumping to NoSQL. What I'm hoping is that people will jump to functional programming. So I went to, John will correct me on this, but it's got to be 5 years ago, might even be 6. So I went to 2 conferences, 6 years? 2 conferences within about a week. I went to Node.js and I went to Progressive F#, I think it was at the time. Yep. And John was there as well. And I was basically going to say, I decided I was going to choose one of those 2 routes to go. And I'm normally pretty good at choosing the route to go. And I said, functional programming is where it's at. That's what I'll concentrate on. And I've been waiting for the day when functional programming's taken off. And I'm looking across at my friends who are doing Java, and they're not doing Java anymore. They're doing Scala and Clojure, and now Kotlin. You know, I look over at JavaScript. I don't look for very long, admittedly, but I do. You know, I have a look over at JavaScript, and a lot of that's now functional. And then I come back to the C# world, and it's, oh. So what I'm hoping is that we can try to get functional programming to be the way forwards. And I'm going to show you today some of the things you can do in C# that maybe you didn't know you could do, or that have come out relatively recently. So, F#. For the public viewing, it came out in 2010. Actually, it came out in 2000. But it just wasn't public. It was publicly available, provided you knew where to look for it, but it didn't come in Visual Studio. It came in Visual Studio in 2010. And now it's a first-class citizen, so when you install Visual Studio, you get F#. It's in other languages, but it's there. Functional programming in C# really started, you could argue it started in 2 with generics, but most people probably saw it when they got LINQ. I take it everybody's using LINQ? Yeah? Good. Okay. So what's now happening is Microsoft are putting new functional features. They're taking them from F# and trying to backfit them into C#. Some of it's successful, some of it's less so. But we'll see quite a lot of it today. So, what is functional programming? Age-old quote, ask 10 people what functional programming is, you'll get 20 different answers. It's different things to different people. I'm going to argue that I think functional programming is functions, there, immutability, and a clear separation of data and behaviour. So I think they're the 3 things you should concentrate on. There's a load of other stuff as well, but if I've only got a slide, I don't want to do 25 million things. We're going to see a lot of things anyway as we go through the code. So functions, first-class citizens. In F#, functions are first-class citizens. In C# they're not, because they have to live within something else. They have to live within a class. You can't at the moment have a free-floating function. That may or may not happen in the future. Don't know. What we're trying to do is to build pure functions. Pure functions are those that take arguments, they don't modify the arguments, they don't have any mutable state change in the middle, in the function, and they return something. So that for me is a pure function. I'm not going to cover what referential transparency is here. Come to that later on. That'll be for the test at the end. Higher order functions. Quite simply, higher order functions are functions that pass into other functions or get returned from functions. So if you're doing LINQ, you're already using higher order functions. Composition. Just as you build objects out of smaller objects, we build bigger functions out of smaller functions. That's all composition is. And finally, expressions versus statements. So a statement doesn't have to return anything, an expression does. So functional languages are always expressions, they're always returning a value. Immutability. Once you create it, it doesn't change. Sounds really dumb. You think, if I change it, why am I going to have a copy there and a copy here? It's amazing how much that helps you. But you're thinking, well, I've got 2 copies. Well, actually, you haven't, because garbage collection's that good that once you've lost track of a use of this one, it goes anyway. So you only have 1, or you might have 2 for a short period of time. Not having immutability means that state can change wherever you want it to. I work on big C# applications, and I spend most of my day debugging multi-threaded, multi-core state changes that I possibly can duplicate 1 time out of 5 if I'm lucky. It's a very frustrating place to be. And we end up turning off multi-core stuff in the end, and we go back to single core just to make sure that we don't have these bugs. So we've got machines sitting there with massively powerful processors, and we hardly use them. We're like 5% usage. It's a bit daft, really. And clear separation of data and behaviour. This is a tough one for OOP people. You know, because you've been taught about anemic classes, you know, just having data. It's not a bad thing, but it is in the OOP world. And by the way, if you've got any questions, just ask. Or if you've got any comments, just say. So, what's the difference between OOP and functional programming? Object-oriented is state and behavior together. Now, I've been writing OO code, or a fashion of OO code, for well over 20 years. I think I can hold my hand up and say I've seen less than 5 actual OO implementations. The majority that I see are object-oriented in the round, so they use classes, and they use classes to build other classes, and then everything else is imperative. So everything else is little jumbled bits of functionality inside a function, or inside a method, and lots of those. I've seen very little that I consider to be relatively pure OO, because it's just so easy to do. It's so easy just to pull some data in, make a decision, go and get some more data, make a decision, send something out. It's a lot harder to write code that actually goes off and says, go and make that decision for me. Now, I might just have been unlucky, but I've probably seen 50 code bases in the last 20 years, and they've all been pretty much the same. But they're getting bigger, you know, so it's actually getting harder to work with now. So functional programming, clear separation between data and behavior. You have functions and you have data. Data gets acted upon by functions. Sorry, that's the wrong way of putting that. Data gets passed into functions and things get passed back out again. So it's all about data structures and passing data structures through pipelines of composed functions. So this is a quote by Michael Feathers, who's pretty famous. I think he was one of the Snowbird guys, the Agile guys that started in 2001. So he says that OOP makes code understandable by encapsulating the moving parts, and functional programming makes it by minimizing them, so you have less moving parts. Now, I said pure functions, you know, you should try and have pure functions. You can't have an application built entirely of pure functions, because it wouldn't do anything. State has to change. You know, you have to get data from a database, you have to receive user input. So the idea is that you put the functions that do the work, that do the state, sorry, the impure functions on the outside of the application, and the pure stuff in the middle that does the work. So if you imagined, if you wanted to take a CSV file and convert it to PDF, so thinking about it logically, what we'd do is we'd load the data in via a function that would turn a list of data. We'd then pass that list into the function that did the conversion. We'd then pass the result of that to something that printed the PDF out. So the bits that do the I/O, the bits that do the state stuff, sit outside of the pure function. The pure function you can test on its own. Rather than the OOP world, you'd probably get the data at the top of the function, do the work in the middle, and then write it at the bottom. And that makes it much harder to test. So you end up having mocks. And obviously, as you extend this, then it makes your code harder and harder to reason about. Functional programming should have small functions. A lot of the OOP code that I see doesn't have small functions. It has quite sizable things. So, it's not me jabbering. Let's look at some code. Right, don't be scared. It does say F# workshop. So what we're going to do is I thought it'd be a good idea that this is a very nice F# workshop that tells you about 16 things that functional programming does. 16 features of functional programming. But I thought what we'd do is work through the exercises, but do them in C# rather than F#. So that way you get to see what the F# bit looks like and what the C# bit looks like. And I can tell you when the new features are coming, so when the bits from F# will appear in C# if they're not already there, Or if they're already there, we'll try and use them. Sound good? Okay. A really good exercise. If you want to learn F#, it's a really good place to go. So, let's start off with bindings, functions, tuples, and records. So the first thing we're going to do is create a customer type. So this is a simple data store. This is immutable, and it's got 3 properties on it. So this is called a record type. It was supposed to be coming out in 7 point something or other, but it got canned. It's supposed to be coming out in 8 point something, but I wouldn't hold your breath. I'd probably wait for 9 before it comes out. But we've got an equivalent to this. So if I go and have a look at, so I've got 2 projects that I've done here. I've done a finished version, so I can copy and paste stuff, so I don't have to type too much. And then I've got a start one as well. So the way that a lot of functional applications get written is they have, for each functional area, for each domain area of the code, bright sun, you'll end up with 2 files. You'll end up with a types file, which contains all of your classes, and you'll end up with a functions file, which contains all of your functions. So we can't do a record type at the moment, but record types are coming. So a record type is something that is just a very quick immutable data structure. But we can write a read-only class. So they're dead easy. We just have a constructor that takes all the data in, we set it in the constructor, and we just have getters. I've put a little helper toString on there just so I can read the data out. Nothing magical. And then all this is doing is creating a customer. So I'll do that just for the sake of doing it. So over to program. Just to show that it does work. I'll do a oh, that's better. I'll take back everything I've ever said about you. So I'll just do a toString and do a read line just to stop it blowing up. Oh, I'm not going to resharper on this. Right, so if I run this, it should just right. If I set the startup project to the start one rather than the other one. Yeah. So I just got some data back. So nice and easy. Back to our idea. So we've got a little function here called try to promote to VIP. So it says that's got a little internal function there as well. It's a tuple. Okay. So in version 7, there's a new type of tuple. We now have a value tuple. And a value tuple allows us to do funky things like this that we never used to be able to. So instead of having to do tuple of customer, comma, decimal, we can now just write it like this. So all this is doing, so it's doing the tuple first, and then it's a simple, I'll come back to that in a second. Oh, I've still got functions open. So if we try and match this, so try to promote to VIP. I'm going to make it static, so all of your pure functions should be static. So try to promote to VIP. Okay, and that took the tuple in. So let's see if we can do that. So it takes a customer and a decimal, and it was purchases. Oh, I need to return something. And that function returns a customer. So in F#, the last line or the end of an if returns it. So in this case, it's returning a customer. So I've got a little function that takes a tuple of customer and decimal and is going to return a customer. So let's deconstruct our tuple to begin with. So var well, looks like it's working. So we can deconstruct a tuple now. Tuples are fantastic. If you've only got 2 bits of data or 3 bits of data, you don't have to create a class. Just use tuples. They're dead easy to work with now. You can even name them in C# as well. So you name the items in the tuple. And you can see their deconstruction's dead easy. So what was my logic? So if the amount's greater than 100, I'll do that for the moment. And then by default, I'm going to return the original customer. So we go back to this. So one of the things we can do with the record is you can create a new record that's a copy of the old one, but change some of the data. Now we can't do that in C#, unfortunately. So what I tend to do in this sort of case is do a fluent interface and do a builder. Don't know if any of you have seen those before. So I'm going to copy it from my finished one because it takes quite a while to do. Oh. Sorry, I need to get rid of the things that are not necessary at the moment. Okay, so this is a fluent interface. This is not functional. You've been able to do this virtually since the beginning of C#. What you do is you take in something that you want to use, in this case a customer, and then you set up a set of public functions that take in values you want to change, and then you return the instance of the builder that you're working with. So what you can do is, if you want to change that customer, I can now do a new customer builder. That takes the original customer Oh, why have I got that? I've got that because it's inside there. Right. Sorry, I'm getting there. Right, so I've got one back now. And what this does is, what we've done here with this record type is we've set is VIP equals true. So I'm going to do dot with VIP. I'm going to set that to true, and then I'm going to do dot build. So it's a little bit of extra effort, but I've got something that that helps me do that. Otherwise, I've got to literally copy all the properties and change the things I want to change, which is much harder. And this is much more readable as well. So it's just test that it works. So it's try, no, I've forgotten what the function's called now. So my function's called try to promote to VIP. Copy and paste.
These functions on there as well. It's in the functions class.
Yeah, I'm used to having resharper again.
These functions dot try to promote to VIP.
I do. Why doesn't like that? I've got no argument in there yet. Okay, and if I copy that. Hopefully that will okay, so that's changed VIP to true. One of the other things that we can do as well is I don't like this functions dot thing. So one of the things that's been introduced in, I'm trying to remember when it happened, I think it was 6 that it came in, is that you can now do using static functions, and what that does is just loads the statics in that particular class. So I can get rid of functions. It should work, so why am I not doing it?
Start functions.
Yeah. Oh, it should be all right. It's in the same namespace. Oh, there we go. Right, just need a little bit of extra help. So that's I think that was introduced in 6. So you can so things like the math class in system, if you just want to take all of those, rather than having to do math.pi or math.square, you can just use square. Just tidies it up a little bit. I don't know whether it makes that much difference, but it's there and available. Okay, the next one's a simple function that takes a customer, returns a tuple. Yep. So get purchases. So public static, oops, no, it returns a tuple, doesn't it? Takes a customer, returns a tuple. So it takes a customer in there, returns one of these. So if I copy that, okay, and there's an arbitrary bit of logic in there. It doesn't matter what it does. It's just the fact that you can. It's the fact that you can now pass tuples in as parameters and pass them out as the results of functions as well, in a nice clean way. So if customer.id modulo 2 equals 0, so 120 and 80. Okay. And obviously I can run that function as well. So what we've covered in that is we've done some functions, we've done some tuples, and we've done what the equivalent of records are on there as well. So, next page, higher order functions. Before I go on to higher order functions, what I want to do is I want to load a LINQ pad. Does anybody use LINQ pad? Fabulous tool. So the other great advantage of LINQ pad is that it supports all the C#7 stuff. So if you want to try it out, you want to try things out, have a go in LINQ pad. You know, you haven't got to run a full program in Visual Studio and download the SDKs, you know, for 7 and 7, 4.7, 4.71, 7.2. They're already in with LINQ pad. Right, can everybody read that? Ooh. There we are. I'm sure everybody can read that now. Anybody recognise it? Or think they know what it might be? There's a subtle clue in the title of the page, but it's basically a decompiled version of the where clause from LINQ. I think this is quite interesting. Has anybody actually decompiled LINQ and had a look at it, see what's in there? It's quite fascinating. It's quite an eye opener what they actually do. So the interesting things that come out of this, provided predicate. So this is using higher order functions. So it's passing in a func of t and bool. So it's a function that takes a parameter of t and returns a bool. There used to be a predicate type, but I don't think that seems to have gone out the window now. That seems to have been pushed off to func of t and bool now. So this is a higher order function because it's taking in a function. Provided that predicate is pure, it's also a pure function. because TS doesn't change, and you return a brand new immutable from this. The other one that's interesting here is that this word, it's an extension method. Basically all of LINQ is extension methods. Which is really interesting, because the number of people I talk to and I say, you know, do you like LINQ? I've never met anybody that doesn't like LINQ. Oh, okay, thank you. it was going to happen one day. So I've met people who sometimes think, so I use ReSharper, and sometimes I can't think, particularly a few years ago, I couldn't think, how do I solve this? I'll do it in an imperative way, and ReSharper came up and said, I can convert this to LINQ for you. Oh great, that's normally really good. Convert it to LINQ. And I got that. And I'm just looking at it thinking, no, you know, it may be clever, but I'm going to look back at this in 3 months' time, 6 months' time, and think, what on earth does that do? So we reverted it back again. But most people like LINQ. Most people think it's really good and handy. So the next question you ask is, do you use extension methods? And that's the work of the devil, apparently. Most C# developers hate extension methods because they're told to put functions on objects. Having them as separate classes doesn't fit in their brain properly. So it's quite a weird one. So yes, this is some basic LINQ. It's a pure function provided predicate's pure, and it literally just loops through, picks some value out, and yield returns something brand new. Just as an aside. So the next function is increase credit. Condition in this case is a function. Because I read underneath and it says if condition customer then. Okay. So I'm not going to write that, I'm going to copy that one over. Save me typing. This is where I wish I'd got ReSharper on this box. Right, that should solve that problem. So this is basically, again is using the builder that we used previously, and just shows you that you can pass in a higher order function. But we know we can do that because we saw the LINQ. Close that down. No. Right. Ooh. The next one, partial application. Now this is one of those really odd. Well, it's not odd. It's a very powerful thing. But it's one of those that doesn't translate to C# very well. I'll give you an idea of what it does. So this is something called currying. So in F# you have two ways of passing, or in functional languages you have two ways of passing parameters. You can either send them as tuples, So that comes in as one thing, but one thing together, or you send them in as separate inputs. Technically, you're not sending them in as separate inputs. What you're actually doing is creating multiple functions. So in most functional languages, a function takes one parameter and returns one parameter. So if you're taking two parameters, what you're actually doing is you're creating a brand new function that takes one parameter that then gets passed on to the next parameter, and that gets added on. And it doesn't really work well with C#. So if we look at that bit of code that's commented out, so we take a func of string, 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 and we'll have a function called join, and then we just use a little bit of lambda on there. I've created a couple of extensions here because what I wrote there isn't what is actually happening. What is actually happening is this thing underneath here. So the next stage is function composition. So if you look at this takes, if you work your way down, you've got customer gets passed in, customer gets sent as the last parameter and returns a customer, I think that is. The result of that then gets passed in as the last parameter or a parameter into this that returns something. This something then gets used at the end of that. That looks very much like LINQ to me, because that's what LINQ does. All those dots are effectively doing what we've done here. They're just a nice way of doing it. You still create all those intermediate bits, but you just don't have names for them. So let's try and do that. So I've got get purchases. Oops. Upgrade customer, text customer. Right. So let's create our function. Static void, say upgrade customer. That takes a, I'm assuming that's going to return a customer. So it takes customer, right, so the first thing it wants to do is do the get purchases. So I'm going to cheat a little bit here. So that's get purchases, and that returns a tuple. Okay, so var purchases equals get purchases. That takes my customer. The next one does a try to promote to VIP, so we've already got that function. So that's that one that takes the tuple. And the last one is increase credit using VIP. Let's remove that. So that takes a customer. And it takes a func. and that's the VIP thing that we didn't do. So that's that thing there. So we've got a func of customer to bool. So func of customer to bool. Which I can't do. Sorry, I'm going to copy my one that I did earlier.
What was the point of the var VIP then?
Sorry, yep. So I need to pass that into there. Sorry, yes, correct. So that's what we've got so far. I can't use LINQ. I can't use LINQ style at the moment because these aren't extension methods. So quickest thing to do there is to use extension methods. Just to go and put and see what breaks. Nothing's broken there, which is good. So I should now be able to do return get purchases.customer dot try to promote to VIP. Okay, well spotted. Okay, so that's a way of doing function composition. So what we're doing is we're building up a bigger function out of smaller functions, but we're not doing it in one go. What we're doing is doing individual bits and chaining them together. So the first thing that people say when they see this is, but isn't it more efficient to do it in one function? Yes, it's possible that you could have savings. If you put it in one function, there could be optimizations in there that you could find, but then you're making it harder to read. You know, it's do you make things so that they're very easy to read and to work with, or do you make things so that they're fast? Most of the time, machines that we run programs on are plenty fast enough. You know, if you save a few milliseconds optimizing this function, that's nothing compared to one call across the network. So obviously if you're working in banking, you need every millisecond. That makes a difference, but I don't work in banking. Okay, so back to one of the fundamental idioms of functional programming. You know, it's write small functions, compose them together into bigger functions. Dead easy to reason about, dead easy to know. If there's a problem, it's easy to find where the problem is. That's the core of functional programming. Along with immutable data and pure functions. Right, so those of you who were looking at my opening screen on PowerPoint will have seen the F# forward pipe I love. That forward pipe literally passes whatever's on the left-hand side to the right-hand side. So in this case, it'll pass customer as a parameter to get purchases. What gets returned out of that will get passed as the parameter to try promote to VIP, and what gets returned from that will get passed as the parameter into this function. So it's the F# way of doing dots, in effect. It's not as neat as dots, I will admit, but this is nice and readable. You know, it's nice and easy to follow. And then there's another way of doing it. Because function composition is such a thing, we do it that often, you can use the double pipe operator. I prefer the previous one, to be honest. That's just clearer.
Are they functionally the same?
Yes, they're exactly the same.
Easy to type.
It is, yes, but then 6 months down the line, you know, I can look at that, and most people could look at that and understand what it meant. Whereas the cleaner version, people look at it and think that's F# gobbledygook again. You know, got to try and work out what it means.
Can we just scroll back up again? You've lost the customer parameter or argument. So the first one, the customer, you're doing the forward piping to get purchases, but the bottom box.
Yes, it infers it.
Right. Okay.
It's clever enough to know that get purchases takes a customer.
Okay.
So when you call upgrade customer, it would still take a customer as input. Yeah, it's a bit voodoo-y in places.
There's a lot.
Yes. So, some more fun. Options, pattern matching, discriminated unions. We'll ignore units of measure, 'cause can't do that in C# at all. It's just compile time sugar that F# can do. So options. I've not mentioned the word null this evening at all. So in F# and all functional languages, null is not allowed. It's not strictly true, but we try not to use it at all. We try to use other options instead. And options is a key word there. So an option type you can think of as being pretty much like a nullable type in C#, except it works for anything, not just value types. C#8 will be getting one of these. Be interesting to see how they implement it, because I've done an implementation of it in this and it's not very nice. So we'll see how, if they've got access to the lower levels of the language, if they can make it neater and easier to use. So what we're going to do is we're going to add so there's a few bits in this. We're going to add a personal details. This is a record type, so I'm going to create a new class called personal details. So I'm not going to do that. I'm just going to nick it from the finished version. I should get this roughly the right place. Okay, so what we're going to do is we're going to add personal details in. But what we're going to do is we're going to make it an optional type, so it doesn't have to be provided. So just like if you've got a null in a database, you know, you've got to handle that when you get your domain model out. You need to have something in there to say there's no data, but we don't want to use null. So the idea of an option type, so obviously nullable types has something called has value and value. Now obviously we're not talking about value types here, we're talking about other things. So what an option does generally is it has a concept of none, i.e. there's nothing, or some of something. So there's either something with a value or there's none, and that's an option type. So if I oops. So I need to show you what option looks like. if I could find it. It's in common, that's right. Right. So this is all option. So I said sum of t, so it is literally SOME and a value, or it's none. And I have some little helper functions here as well. Obviously, because this is the first class support in F#, we don't need to do all of this sort of stuff. Hopefully, you won't need to do all of this when C#8 comes out. Hopefully, it'll all be nicely done for you. So the idea is that by making this an option of something, so if I go into my types, so if I make this an option of help if I copy the so I highlighted them and then didn't copy them over. So I take all of that, that's in common. Make sure I paste that in the right place. And that should be okay. So we now got that. So an option of personal details. Which just got a getter. Obviously need to pass that in as well. And okay, so what impact does that have? Well, obviously when I create a customer, I've now got to handle this, so I've now put an option in there. So because I'm using the builder, let's go and have a little nosy at what we need to do with the builder. Not too many things on here. Right, so obviously my builder won't compile anymore because it needs that option of thing coming in. So let's go and add private option of personal details. Okay, I'll do that there as well. So with personal details, and sorry, I'm trying to do this without making mistakes. Right, that should be it. That should compile now. Okay, I'm missing using again. Okay, I'm going to comment that out for the moment. I don't really want to look at. Oh, I know why. Because we can't create the customer first of all. So so I'm creating a new customer. So let's have a go and see if we can sort that out. So if I haven't got personal details, I need none. So what I can do is I can do none dot value. Oh, I've got my this stuff again, haven't I? I'll ignore that for the moment. So let's copy that line and let's try one with the sum. So what I'd normally do in F# is just do create a new personal detail. In fact, I'll do that anyway. What do we think will happen there?
Is that equivalent to none?
It looks pretty much like it, doesn't it? So let's try and see what happens. See, part of the thing, because you're making small changes with functional programming, one of the things we tend to do is play around a lot, to be honest. Just try stuff out and see if it works, and if it doesn't, try something different. So let's run these and see what happens. Let's build it first, see if it says that's okay. So I haven't got my on my toString for the customer. I've not put it on for the personal details yet. Right, let's try again. Okay, so what I've got there is the equivalent of none, because if I look at my little helper here, I've got something called reduce, and what this does is takes that option of personal details and says if it's none, I can't use null because we're not allowed to use null. So what I'm going to do is give you some values. So if you imagine I was saving this back to the database, so I'm saving 3 fields back to the database. I can't send null. Actually, I could send null if I wanted to. I could put null into this. But I don't want to in this case. I want to put in empty string, and date time today. But I could have put nulls in there. So the idea of option of T is that your domain model can contain semantic meaning. So it can say, this is, you can provide this or not provide it depends. And then when you come to store it in the database, you can store it in a completely different structure. So you can convert one from one to the other quite easily. The same from, if you think about it from user input. User input isn't going to be in personal details. User input is going to be 3 fields. And that may come through with data, may not. And then you've got to convert that to an option of personal details. So the whole idea of an option is you've either got data or you haven't got data. So this is just a way of handling that. So we need to work out how to get some data. So to save me typing, so that comes through. The reason I can type in just the new personal details and not have to bother about option is because of some of the work that I did on the types. So the type has an implicit operator that will convert whatever you send in. If you send in some data of that type, it will automatically convert it to a sum of that type. You don't need to do any work on it at all. But as I said, this will be done properly in C#8, and will be much more obvious how it's supposed to work. But this concept of being able to build domain models that are not just series of properties, but actually properties combined into other things, and that you can tell it that that thing can be there or not there very easily, is a really powerful thing. So I use this all the time. I use this type of structure. You know, how it's stored and how it comes in from the UI are two totally different things. The data structures are completely different. But how I manage it in the middle is how I want to make my domain model look. So when somebody from the business looks at, and when we talk about one of our structures, we talk about personal details, and it means something to the BAs and the modelers. Whereas giving them 3 fields of first name, last name, and date of birth, you know, in that case it's probably okay, but it's actually, they actually have business meaning combined together. And there may be some rules that go with them as well. So you can combine that into this as well. So option of T is going to become very, very important. Discriminated unions. So the idea of a discriminated union, so what we'll have a look at here is notifications. So notifications can either be no notifications, or you want to receive notifications and it's whether you want to receive deals or alerts, or and alerts in there as well. So they're two different things. So that's all we need to type in for F#. If you compile this and decompile it in C#, what you actually get is an abstract class called notifications and 2 concrete classes, one called no notifications with no body, and you get receive notifications that has 2 properties on it. So it does compile down to C#. It's still IL at the end of the day. It still works in C#. It doesn't quite have the same meaning as it does in F#. So in F#, if you want to add extra things, you've got to add them onto the discriminated union. If you want an extra concrete type, you can add it wherever you like. You know, nobody could know about it. Whereas with this, it's in one place and that's it. So the idea of this, again, we're going back to our domain model. Our domain model isn't two properties, so it isn't a property that says receive deals and receive alerts. What it actually is meaning. It means you're either no notifications or you want to receive deals or alerts. So your domain model can contain a notifications property rather than two separate properties that you need to just handle separately. Does that make sense? Okay. This is a very powerful thing in functional programming and domain modeling. One of the big things that's come out over the last couple of years is everybody thinks functional programming is for maths geeks and for people who deal with millions of rows of data. It's not. Functional programming is for everybody. Domain modeling in a functional language, particularly F#. There's a book out there by Scott Voloshin called Domain Modeling in F# Made Simple, I think it's called, or Domain Modeling Made Simple. So he takes all of these businessy type problems or domain problems and writes F#. Does all of this in F#, and a lot of it. So a sales domain could be written on a single page, the whole domain model for a sales system. It's a very powerful set of tools, but people don't look at it because they've been told that functional programming is not for the stuff they do day to day. But actually it is. You can be much more productive in a functional language. You might much less code, and it's still just as readable, if not more readable, because you've got less noise there. So as I said, notifications will be So notifications is an abstract class, and then there's a class called no notifications, which I've just put an overrider toString in there because I felt like it. And then there's a receive notifications that is just an immutable class again. So if I go back to my original type, so I need to copy those out again and put them into my new class. So I've now got a public property called notifications. Sorry, of type notifications. That I can pass in. So I probably need to add the thing to the toString as well. So far it's like whoopee-doo. Okay, so we've got a bit more semantic meaning about the domain. How do I actually use this? Well, that's where the other thing comes in, pattern matching. So pattern matching came in C#7. What you've got in C#7 is about 10% of what F# can do. You're going to get another 20 or 30% in C#8, but it's still not the whole lot. There's a load of other stuff as well. So the idea of pattern matching is, has anybody ever been told never use a switch statement? It's bad to use. Now pattern matching is coming in, switching's good again. Sorry, but that's just the way it is. So, to find my instance of this. I lost where I am now. Oh, don't want that. No, I do need to be in functions. Right. So what I'm going to do, so this is a function which is get alert. And what this does, so this is it's an extension method as well. So it takes a customer, and what it does is it switches on customer.notifications, and the pattern matching part is the fact you can match on types now, which you've never been able to do before in a switch. So because we're storing, they're either no notification or they're received notification with some data, we can now pattern match on that. So rather than having to do if thens and everything else and try and, if you've got 4 or 5 parameters, trying to get all the combinations isn't going to work. This is a much more powerful way of doing it. It's a much more readable way of doing it. So if we take receive notifications, and you get a little thing like you do in LINQ, all the Lambda stuff, that you can then say, does it want to receive alerts? If it does, do something. This little underscore here is a wildcard. It just means I'm not interested in that. And in that case, I don't want alerts. And the other one is just saying, you know, I'm no notifications anyway. The thing to take away from this is the three things we talked about at the beginning, which was pure functions in particular, you know, higher order functions, all about functions. Immutability. If stuff doesn't change, you're not going to break it. That's not strictly true, because obviously you've got reflection, and I know a lot of people that because they can't get at a private variable will just use reflection to do it. So yeah, it's one of those things, and that separation between data and functions. You know, have small classes of data, you know, that mean something, and pass them off to functions to do some work. It's dead easy. Can't combine them together. It's dead easy. So where can I learn more? The first book is really good. What he's done is write a library that takes all the things that you learn from F# and put them into C#. It's much nicer than the stuff that I've done here, but it's still a little bit over the top. I personally, yeah, it's a good book. If you want to read about functional stuff in C#, that's probably my favourite book. Second one, it's not as good, but it's a little bit easier to follow. The third book on the end, though, I have a copy here, which I'm giving away, is the real deal. F#, read it, you'll be converted. You won't want to go back. With that, thank you.